Yeah, too much pressed. Fix it. And the outer one, this one should be closed. This one should be closed. And this one should be open. This one should be open completely. It should be pressed. To check whether the connectivity is perfect, press this. I cannot press it. Even if I press, it will come back to the original position, and there is no connection between the external atmosphere and the canister. Now this is okay. You can keep the paper and this. Now what you have to do, you have the temperature and the tea water. Switch on this. Keep something. It is heating up. When the temperature is 30, when the temperature in the thermometer is 30 degrees or 29.5, you take this and immerse in this. Up to 90% or 85% of this should be inside the water. You keep it for 1 minute.
Yes.
You keep it for 1 minute. You can see the watch. And during that 1 minute, this expands. This will expand like this.
Yes.
This will goes up. And how much distance it will travel? The length you write here. The delta L you have to write here. At the end of the 1 minute, you bring it back. You remove this. And take this to water.
Yes.
And this keep in the water for 1 minute. By meantime, bring this back. The temperature keeps rising. And again, you connect this to this. Check it. It is it's not perfect. Yeah, this is not closed. Yes. This is perfect. Now if I say 40 degrees, when it is 39 degrees, you insert in this. By 1 minute, it may reach to 40. By 1 minute, you are allowing to expand the piston. By the end of 1 minute, how much distance they have traveled, you can write delta L. How much temperature ranges are given, you do that. Now, after finishing this, you have to calculate delta V.
Yes.
You have to calculate delta V, change in the volume. How to calculate delta V? This is a formula, pi r square into delta L. What is R? R is the radius of this. This is big bore. That will be given in your
Yes.
question paper. What is the radius of this? It will be given there.
This is delta V.
Delta L is this. Delta L is the?
I want to calculate delta V.
Delta V is the formula, pi r square into L.
Can you come second?
R is the radius is given. The L is this is the delta L.
Yeah.
You can multiply this and don't forget to convert millimeter into meter.
Okay.
Don't forget to convert millimeter into meter. You are getting this, the volume. And you have to draw the graph between delta V versus TW. This is delta V.
Yes, and this is.
And TW. And get the slope. By using the slope, you can get the C, the number of moles, sorry, N, number of moles. C is the constant.
That's
The number of the mole is equal to slope into P over R. You know how to calculate slope? P
Yes.
is the pressure. 1 atmospheric pressure convert into Pascal. 1 atmospheric pressure is 1.0. 1 into 10 to the power of 5 Pascal. And the R, universal gas constant, you will be giving that. You can calculate this and get the number of moles. Yes. And get the number of moles. What could be the major source of error in this experiment? There are many major sources of error. The first one is the temperature.
temperature.
The first one is temperature. The second one is delta L.